Hello everyone, my name is Tarandeep and today we will be learning about inorganic chemical reactions. This includes synthesis, decomposition, single displacement, double displacement, incomplete and complete combustion, neutralization, and the formation of acids and bases. Now let's get on with the video. To begin, let's discuss the two types of reactions, endothermic and exothermic. In an endothermic reaction, heat is absorbed, while in an exothermic reaction, heat is released. The simple rule is when chemical bonds are formed, heat is released, and when chemical bonds break, heat is absorbed. Synthesis. A synthesis reaction occurs when two or more reactants combine to form a single product. A simple way to look at it is A plus B gives us AB. There are categories of synthesis reactions, which includes the production of oxides, binary compounds, acids and bases, and the production of metal carbonates. Today's focus is the production of an oxide, which is a chemical compound that contains at least one oxygen atom. In this type of reaction, metals react with oxygen in the air to produce metal oxides, as represented by the equation shown. For example, let's say magnesium reacts with oxygen to produce magnesium oxide when it's heated in the air. So this would be represented by this equation. Magnesium plus oxygen gives us magnesium oxide. The triangle on the arrow indicates the heat that is being used. And now let's balance. Now it's your turn to try. So a piece of calcium is reacted with oxygen to produce calcium oxide. Decomposition. A decomposition reaction occurs when one reactant breaks down into two or more products. So it's like a pair of best friends that aren't friends anymore. It can be represented by the general equation AB breaks down into A plus B. So there are two types of decomposition reactions. So the first one is thermal decomposition, and the second one is compounds that give two other new compounds. Thermal decomposition is using heat to break down the reactant, forming two or more products from one reactant. An example of this is breaking down copper carbonate. So copper carbonate breaks down into copper oxide and carbon dioxide. Since this uses heat, the triangle on top of the arrow indicates that, and it's considered to be a thermal decomposition represented by the equation shown. This also forms two new products. Now it's your turn to try. So what does magnesium carbonate break down into? Magnesium oxide and carbon dioxide. Single displacement. A single displacement reaction is a reaction in which one element is substituted for another element in that compound. So this can be represented by AB plus C equals AC plus B. So you can imagine this as AB are dancing partners, and then C comes in and says, I want to dance with A, and then they switch, while B is left alone. So some rules that you should be following while displacing are treating hydrogen as a metal, treating acids such as hydrochloric acid as ionic compounds, and treating water as an ionic compound with the formula H as a cation and OH as an anion. Either a metal can displace a metal or a non-metal can displace a non-metal. So when you're doing either one of them, you always have to look at the activity series, which indicates the reactivity level. So here is the activity series. So the metals at the top are the most reactive, and at the bottom they're the least reactive. So when you have to displace, you have to look at this. And then this is for the nonmetals. So the nonmetals, the same thing. The top is the most reactive and the bottom is the least reactive. If we're doing a non-metal displacement and C wants to take the place of B, we look here, and if B has a higher reactivity than C, there will be no reaction, but if C has a higher reactivity than B, there will be a reaction. So, for instance, we have chlorine gas and sodium bromide. We're going to use the activity series to determine whether or not chlorine is more reactive than bromine. So here it states that chlorine is more reactive, and since it is, it will replace bromine in the equation, and therefore it will form sodium chloride, and bromine will be separated from this. Now it's your turn to try. So here we have fluorine gas and sodium chloride. So figure out whether or not it replaces it. So it does replaces it, and that is because in the activity series, chlorine is below fluorine, and fluorine is the highest. Therefore, it will take the place of chlorine and form sodium fluoride. And now we have double displacement. So in a double displacement reaction, parts of two ionic compounds are exchanged, making two new compounds. So this is showcased by AB plus CD equals AD plus BC. So in this case, the dancing partners are exchanged. A has gone with D and B has gone with C. Something to always remember is that reactants are always aqueous. A double displacement reaction only occurs if there's a formation of a precipitate, production of a gas, or the formation of water. If this does not occur, then there is no reaction. In this video, we will be focusing on neutralization and precipitation. A solubility guideline is a chart with a list of ions, and it states whether they can become precipitate or remain aqueous. So here for hydroxides, it states that is insoluble, so the exceptions, that would mean that those ones are soluble and are aqueous, and insoluble means that they form a precipitate. So it is a double displacement reaction. However, if both are aqueous, then there is no reaction. For the production of a gas, you will have to memorize that carbonic acid breaks down into water and carbon dioxide, and ammonium hydroxide breaks down into ammonia and water, therefore forming gas and water. For example, we have nitric acid and sodium carbonate. To figure out what the products are, we simply switch the anions and we get carbonic acid and sodium nitrite. So the carbonic acid breaks down into water and carbon dioxide, so we have to be careful with that, and that is represented by this equation, so there's a two-step process. In neutralization, an acid and a base react to produce a salt and water. The salts are ionic compounds consisting of an anion from an acid and a cation from the base. A simple way to look at it is acid and a base create water and salt. Incomplete and complete combustion. In a combustion reaction, a substance reacts with oxygen from the air and transfers energy to the surroundings as light and heat. Either the combustion reaction can be incomplete or complete. One of the differences between the two is that incomplete combustion produces carbon monoxide, carbon dioxide, and water and other oxides like sulfur dioxide, while complete combustion only produces water and carbon dioxide. Another difference is that incomplete combustion has an orange flame and complete combustion produces a blue flame. Incomplete combustion occurs without a sufficient supply of oxygen in comparison to a complete combustion, forming acids and bases from nonmetal and metal oxides. Acids have a pH less than 7, while bases have a pH more than 7. Acids are formed using nonmetal oxides, and while bases are formed using metal oxides. To form an acid and a base, they both require water as one of the reactants. Here we have two examples. For the acids, so we have sulfur dioxide and water, which gives us sulfurous acid. And for the bases, we have potassium oxide and water. The potassium oxide and the water combined gives us potassium hydroxide. The hydroxide indicates that it's a base. Now it's your turn to try. So we have one for the acids and one for the base. For the acids, the different one is dinitrogen trioxide, and for the base we have barium oxide. So this produces nitrous acid, while this produces barium hydroxide. Therefore, it's a base. So thank you for watching, and I hope this video helped you gain a better understanding of the inorganic chemical reactions.